In part 2, we are given a list of conjectures or statements that have not yet been proven true or false, and we must prove that they are either true or false by using our trig ratios. Our trig ratios are sine of x equals the opposite side over the hypotenuse, cosine of x equals the adjacent side over the hypotenuse, and tangent of x equals the opposite side over the adjacent side. This is also known as SOHCAHTOA. So we'll go ahead and start with number 5. Cosine of A equals sine of A. So cosine of A equals B over C, and sine of A equals A over C. So these are clearly not equal, so this statement is false. However, cosine of A does equal sine of A only when A is equal to B. In other words, these are equal when the triangle is an isosceles right triangle. Now let's take a look at number 7. Sine of A equals cosine of 90 degrees minus A. Now we know that sine of A equals A over C, and we want to find what cosine of 90 degrees minus A is. Well, what the triangle angle sum theorem tells us is that angles A plus angle B plus angle C is equal to 180 degrees. Now we know that angle C is a right angle, so we have A plus B plus 90 degrees equals 180. We subtract 90 from both sides, so we get A plus B equals 90 degrees. So B equals 90 degrees minus A. Now we can substitute this B into 90 degrees minus A, so we have cosine of B, which is also A over C. So A over C is equal to A over C, so this statement is true. Now let's take a look at number 11. This is sine squared of A plus cosine squared of A equals 1. We need to note the following convention that is used to write sine of A squared. This is equal to sine of A times sine of A, which equals sine squared of A. So we know that sine of A equals A over C. So we write A over C squared. And then cosine of A equals B over C. So we write B over C squared. Now this is equal to A squared over C squared plus B squared over C squared, because we square both the numerator and the denominator. So since A squared and B squared have the same denominator of C squared, we can write A squared plus B squared all over C squared. Now here we can use the Pythagorean theorem. The Pythagorean theorem tells us that A squared plus B squared equals C squared. So we can substitute this in to our fraction. So then we have C squared over C squared, and this is equal to 1. This is what we wanted sine squared of A plus cosine squared of A to equal, and 1 does equal 1, so this is true.